Okay. This is fine, okay, right? First of all, thank you very much, sir, for giving me this opportunity. Because usually people in our country do not give us this kind of opportunity to express ourselves, who are we and what we are doing. That's it. Thank you for that. Okay. Here in this presentation, I'll be describing basically what is forecasting and what is the relevance of that so-called sustainable development. Let me introduce myself. I am Malik Fernando, working as a meteorologist since it's been 3 years working at the Department of Meteorology. So NWP, yes, it's numerical weather prediction. I'll be describing that later in a kind of a deep sense. So here we go. I had a kind of a content page here. So basically I'll be describing what is weather and the observation. You have been participating in a presentation at our department, so observation might have covered, and forecasting weather, what are we doing as forecast, and then sustainable development. Of course I got a few slides here because I am not an expert of this subject, but of course I can have kind of an idea about this topic. And tsunami warning system, I don't know whether you are interested in this. If it is, then I can describe it as well. Let's go for the weather. Weather is kind of a thing that is specially, or that is depend on the atmosphere. Here it's your childhood, these things have been learned, I think, if you remember. So if we are considering about the weather of Sri Lanka, it's basically the troposphere and as well as stratosphere which is related to the weather. So we can manage to talk about these two layers, or the single layer, that is troposphere. So especially weather related hazards or weather related things goes with this first layer. And I told you weather is the state of that atmosphere, and in the sense of we are feeling them, we can divide them into few parameters. Especially in Sri Lanka, it's the rain that we are most interested in, and so on and so forth. We can consider and the other parameters as well. But here in Sri Lanka, we are basically concerned about the rainfall or the precipitation. For your information, this is the climate of Sri Lanka. We got 4 seasons. Of course, it is not much divided 4 seasons, but we have identified these 4 seasons. The figure shows this. The first Sri Lankan map is the southwest monsoon, and the other one northeast, so on and so forth. I tell you that the most important pattern or the most important season is the second intermonsoon. Why I am saying that? Because you can clearly see when it comes to the southwest monsoon or the northeast monsoon, rain is accumulated kind of a portion of Sri Lanka, but in the second intermonsoon, the rainfall has been divided into whole country. So when someone asks me what is the reason for the continuing drought condition, so it's the second monsoon which fails last year. That's it. So if we are considering about this season or the southwest monsoon, it is about average, yes, about average, not much lower. People think that the southwest monsoon fails. Yes, it's a failure, kind of a failure, yes, but it is not that much. At the moment, we are receiving rainfalls in Ratnapur area. So it's kind of a typical southwest monsoon, but still we are facing kind of a drought condition. It's because the last year, the second intermonsoon. Sorry, it's year. And you can see the figures, the rainfall variations and those things, and the highest rainfall recorded, annual rainfalls. So these things are here. Another thing, the cyclone seasons. So I'll skip these things. I put this one here because people think many cyclones crosses Sri Lanka. The answer is no. When we look into the history, it's a few cyclones which has been crossing Sri Lanka, because it's a thing with terms. Usually a cyclone got a definition, so it should have kind of a criteria. So I'm just totally talking about the terms, okay, not the disastrous situations. So these cyclones have been crossing Sri Lanka. It's around 12 or 15, something like that. So the last one was not a cyclone, and the previous one as well. You might remember Ronu and those things. Those were not cyclones. Of course, they were developed into cyclones, not in Sri Lankan region. Observation, I just need to have a broader picture. That's why I put here these things. We got 23 main stations. You remember those things. 37 automated. At the moment, they are not working. I think the presenter might have told them as well, because of the communication link. Of course, they are working individually, but we do not have that communication link to get those data to the main station or the Colombo. So people are working with that. In near future, they will connect them through a local network provider. And the rain gauges, approximately these figures are correct. So these things update daily, but over the phone, right? Those were not automated ones, and 500, around 500. So those are updating monthly. So we got satisfactory rain gauges density or the distribution all around the country. But of course, we do not have radar, satellites, and wind profilers, and there are many things that I could include. But the basic things were here. Radar. In 2020, we might receive 2 radars from JICA, from the Japanese government. And satellite, of course, it's not practical here, the satellites. We are not asking for satellites. And wind profilers are kind of a cheaper way to study the upper atmosphere, because when it comes to the forecasting, the main thing or the initial step is to develop observation network. That's the basic thing. Otherwise, we do not get kind of accurate forecast. So I think these are much important. So the GTS, briefly I'll be describing these things. So we are receiving, so we are measuring things, and then we uploaded things to the regional center, and then they go to the headquarters. So likewise, after kind of quality controlling, they will distribute those data to the whole globe. This is the sample of those data. So after delay of half an hour, we can access this kind of data through whole globe. So we are using these things to analyze the present state of atmosphere as well as the present state of surface. Especially the density of data is higher over the surface, not the atmosphere or the upper air. But the thing is, this is kind of a 3-dimensional one, 3-dimensional fluid dynamics we should study. So the upper air or the upper air observation is, we are far behind of that over our region. Satellite images, I heard that the forecast was describing these things. I will skip them. These things as well, kind of a polar width satellite from the US government. We are receiving these things freely. So this is the one that crosses our island. So usually this product is much important. It's again an observation. When it comes to the sea or the sea roughness, this product is much important. This one also might have shown to you. It measures, it observes the total precipitable water around on the atmosphere. So this tool or this observation is much important when we forecast the dryness, because if there is no water amount, in our atmosphere, then of course we can forecast much easily that there would be no raining. But when it comes to the brown region, it doesn't say that yes, it's going to rain, because the precipitable water or the water in the atmosphere is a single factor for the rainfall. So there should be many more parameters that is to be fulfilled to have rainfall. Forecasting, I took this from the Wikipedia, so I think it matches with my idea. So here it's basically about the technology nowadays to do these things. So I'll be describing what is forecasting. I told you about the GTS systems. This is what we are doing. Still, our people are manually analyzing these things, because I am agree with that, of course, because people think that everything should be technology things. Here, in my experience, I have seen, yes, we are doing numerical weather predictions, but most of the time they do not capture our weather phenomena. I mean the models, weather models, they do not capture things. But when it comes to an experienced forecaster, he knows how to analyze these things much better way. Again, it depends on the skill of the forecast, kind of a critical one, because we are much new to this field. I told you it's been 3 years for my career, so these things are much important when we analyze in a true manner, or with the theories in our head, that is fluid dynamics. It's basically the fluid dynamics that we should know when we analyze these two charts. The first one is the surface chart, or the surface observation is being completed. This is that kind of a thing is happening here. We got incomplete set of data, and the forecast is completing those things using his knowledge. That's it. And the second one is an upper air chart. Upper air chart got kind of a lesser amount of data. In our country, you have heard that we got only single radio zone here in Colombo, 3 times a week. So and the other one is the pilot balloon. Pilot balloon usually goes up to 10,000 feet if there is no clouds. But if there's clouds, so again the height drops. So upper air data is the necessary things, but we got nothing about that. Okay, this is kind of analysis again. So you have heard these things in layers. We call them 850 millibar layer, or the hectopascal layer, 700 hectopascal layer, likewise. So we got kind of a standard here. Usually the people in the world analyze these things regularly. So we are going with that standard, and twice a day we are analyzing these wind layers as well, in addition to the surface data analysis. The first figure, or the first picture, shows kind of a depression. Sorry, it's a cyclone. It's a cyclone. The symbol shows that it's a cyclone. So analysis of a cyclone there, and the contours indicate the isobars, or the equal pressure lines contours. This one, yes, the fluid dynamics again. I don't think that I should take much time here. For your information, this is kind of a well related phenomenon for our weather, that is called Madden-Julian oscillation, not Madam, because recently media people, they were calling this one Madden-Julian oscillation. It's not Madden-Julian, Madden and Julian. Madden is one and Julian is another one. Of course, both are men. Okay, so in Madden-Julian oscillation, they have found kind of a pattern like El Nino and La Nina. So there is kind of a circulation over the equatorial area. So once it plays over the when once a Madden oscillation is on the Indian Ocean, then our rainfall pattern or our rainfall behavior is enhanced like that. So this is much important. So this is because of the distribution of energy again. So you might have remembered that we call, once the energy is given to a water column or something like that, it evaporates. That's it. So one side they get evaporate and the other side they get sent. That's it. So the circulation goes on. Okay, it's simple science. So these kind of things are monitoring daily because they are free of charge. Okay, numerical weather predictions. Here, this is the trend of the world. Again, we are doing something. I think it's not enough to fulfill our requirements here in Sri Lanka. Okay, anyhow, we are doing that in a much efficient way, I think. Okay, numerical weather prediction is something like this. Actually, it was began in 1920s in UK. So the two people, Wilhelm. So Wilhelm is the one who developed kind of a system, and then it was implemented by Lewis by hand. That's the thing. So here I put this one, how much it took him to solve those equations to take 6-hour forecast. So he was calculating by hand for 6 weeks to obtain 6-hour forecast. That is what we call calculations. So for your knowledge, usually the supercomputers, we are talking about supercomputers, they were built because of the NWP or the numerical weather prediction. Yes, they are employed with deep space things. Yes, but as far as I heard, this is kind of a bigger reason. Okay, because I told you it's basically the fluid dynamics. So we got a lot of equations. If I'm talking about myself, I do not know what other equations are. I mean, inside those programs, we got kind of equations, thousands of them, thousands of equations in many languages. Usually the languages are Python or something like that. So by observing those equations, we do not know anything about them. That's our situation. So thousands of equations, they are calculating. This is what happening in numerical weather prediction. So I told you about the observation things. Usually they are distributed in random way. Of course, we can arrange them as well, but here they are arranged in a random manner in surface as well as in the upper air observation. So these things are calculated or interpolated to certain grids. The first tip is that. So it is something like this. If we are talking about 1 degree resolution or 110 kilometer resolution, this is sorry, this is not 110, this is 10 degree. Okay, because of our convenience, I cannot put those into 1 degrees. So something like that. Let's imagine we are preparing kind of a 10 degree resolution numerical weather prediction initial data. It would be look like this in surface, only surface. So people interpolated those things, those observations into those grid points. Now we got kind of a gridded values. Okay, now we are going to calculate them, not only the surface but also in the whole atmosphere up to kind of a 0 hectopascal or 10 hectopascal, something like that, about 18-20 kilometers, something like that. We are going to calculate them. And in addition to that, not only that, in the deep sea as well, we are going to calculate them. Okay, so this is kind of that grid pattern. The first image, we got the present situation of the world, that we got sea and land area and the atmosphere or the upper air things, and we are dividing the world into grid points, and then first thing is to interpolate those observed data into those grid points, interpolating those into grid points, and then feed them into equations for many parameters. At the moment we are receiving 150 parameter output gridded data. This is what we are doing. After that, they are calculating the things, not only the surface, okay. This is kind of a totally 3D thing. So we are calculating things on those kind of a matrix. Of course, it's a matrix. So after that, we are calculating things. What happened if these things are prevailing on the atmosphere? What happened to our rainfall? So after solving those equations, we got these kind of observations or this kind of a forecast for the surface area. So here I have included a few of the forecast providers. The first one is done by ourselves, that is called a weather research and forecasting model, which is not developed by ourselves but tuned by ourselves. So it is impossible to develop a model in here Sri Lanka, because it costs lots of money and lots of resources and computing power, many things are there. But this one, like our countries like ours, we are using this model that is available for free. Usually there's a community who are developing these models, so we are employing this model in our department. So at the moment we call kind of a technology data assimilation. Data assimilation means forecast and then it gets the feedback again, feed into the next step. So there's a feeding loop, again it automatically adjusts its accuracy. That kind of a thing is there. Forecast and then observe the rainfall, they get merged and then feed back to the next forecast, something like that. So this process reduces the reduces the wrongness of the forecast, but not much long way. This accuracy of this forecast is around let us say 24 hour or 18 hours, something like that. So again it vanishes. That's it. So for the calculation of this forecast, our computer system takes 5 or 6 hours for 10 days. So it takes that much time in our clusters. We got a cluster system. Again, for some of the donors have given us those systems. Those are not bought by our department or our government. The second one is again kind of a meteorological jargon is there. Some of the phenomena are meet together and then we decide. I told you about the Madden-Julian oscillation. Madden-Julian oscillation we call Rossby waves, equatorial Rossby waves, and those things. If they met together, we decide yes, it's going to have a change or something like that. And the other one, the pink one, it's from European Center for Medium Range Forecasting. That is the best according to the ranking of World Meteorological Organization. But their forecast as well do not perform much better in our weather. This forecast, at the moment we are receiving free of charge. If we are going to buy them, it costs around 7.5 million rupees per year. But at the moment we are receiving them free of charge for next 2 years. So, but of course, I can confidently say among these forecasts, the ECMWF is the best. Okay, the bottom one, this one from Japan, Japanese data. Again, it was this one again from Hong Kong or something like that. they also do not perform better. This one, IMD, Indian Meteorological Organization, this is of course kind of a goodness is there, Indian Meteorological Organization. Here I want to mention that the accuracy of these forecasts totally depend on how much research have we done. Because if the model do not know the weather phenomenon around our sea area, around our land area, then it will never catch our rainfall. That's it. We need to do research and then include those jargons into that model. That's the thing. Yes, here I'm not putting hand on anyone else. We need to do it ourselves because we are the people who are responsible on this subject, and there are some things that, the practical circumstances. So it's around 35 people. Here we are doing the meteorologists, around 35. So we need much more to do these things, to overcome these things, to identify things to these models. Otherwise, I am not talking about the weather apps. If you want, I can talk them later, because many of the people believe that weather apps are quite better. Yes, they are quite better. I agree with that, but under certain circumstances. If you want, I can explain it later. Okay, the ECM, most important thing is here. I just put these things today. These forecasts are much important because in Sri Lanka, we got kind of a hazardous situation recently. These forecasts were much better on those situations. This forecast indicates the extreme conditions when it comes to the rainfall or the temperature and those things, and wind conditions. The 001 is the present situation or today's situation. We can expect kind of a extreme behavior around Trincomalee area today. That is what this indicates. The extreme things calculated this way, they got the average situation. Now they know today the rainfall is distributed this way, but according to the forecast, they are expecting much higher rainfall around Trincomalee area. That is how they have plotted this is a probabilistic forecast. There is a higher possibility for extreme event around Trincomalee area today. So this one was taken today. And the other one, it forecast goes on, and plus 1 day, that is tomorrow, and 2, 3, likewise. Nowadays these patterns are typical. I mean, when I observe the things around past few days, these kind of things were there. But again, I just want to mention this one. This behavior, or the behavior for last week and the next week, is not in the average weather or the average rainfall or the temperature, those things. We got kind of extreme behavior next week and the other week as well. So therefore, even this model did not capture them well. So these models were failure last few days. Our models as well. So again, we got that kind of a doubt that still, the things should be much tuned again for this season, for August, especially for August, something like that. So just forget about it if you are not interested in. Okay, numerical weather predictions for today. These figures, actually I took these from the internet. I'll show you what I have done later. These things are the real useful things in numerical weather prediction. They can simulate 3D many kind of a hazardous situation. So this one shows kind of a intense rainfall around kind of an area. So we can see vertically and horizontally, top to bottom. Okay, all the things can be calculated easily. Again, there is a problem with accuracy, yes, but these things are much easier with new computers. So at the moment we are doing these things in our department. So again, that kind of a 3D model of a cyclone. So I think the first presenter might have told you about the importance of observation, especially when it comes to the radar. Radar can observe many things, that is vertical things, horizontal things, and it can calculate the water columns inside of a cloud, many things. So if we feed those data into the numerical weather prediction models, of course the accuracy get higher and higher. That's the thing. So that these kind of things can be easily modeled using with the help of radar data and the model data. I have done this one. So the purpose was to identify what happened, kind of a intense rainfall was there. Just wait a moment. Okay, there was kind of a intense rainfall around Hambantota area. Usually we do not expect that kind of rainfall. It was around 110 or something like that. But we had no reason for that. Of course, at the moment, when we searching for this, we had no reason for that rainfall. But when we analyzed the data after few days, then we could see kind of a time that is limited around 15 or 20 minutes. It got kind of an intense updraft. So this is what you can see here. So it calculates with the help of the mountain. So wind goes through the mountain, it goes kind of an intense updraft, then cloud form, and then the rainfall again was an intense one. So we can easily plot these things now. i7 computer is more than enough for this with 16 GB RAM. So this is called 3D modeling. We are doing that. Again, this one was not working actually. I wanted to show you the cross section of that 3D column. So this is a single layer. So we can go through up to any level by seeing what is the behavior, where is the point that is going to change, something like that. So this one is not working. The forecast we are doing here, basically it's three types: 24 hours, 48 hours, that is short range, medium and long range forecast. In Sri Lanka we are much interested in long range forecast as well as the short range forecast. These are the main things we are targeting, or our stakeholders here. It's fishery industries and as well as shipping. I should mention this one here again. We are not forecasting only for local people, kind of a thing that people should know. We should provide forecast for the international seas as well. So we need to forecast for next 3 days. We should send that to World Meteorological Organization as well as fleet forecast. I'll show you the region of fleet forecasting and international forecasting things. And when it comes to the seasonal forecast, this one is much important for Sri Lanka because of the things that we are a farming agricultural country. So many of the people require these things, but at the moment I should tell you we are not much better on this subject, but compared to the other countries around our region, we are better. I can surely tell you about that, because seasonal forecast itself got many errors. We cannot exactly forecast the amounts and those things. We are just giving the probabilities. I'll show you them as well. This one a sample of weather forecast and severe weather advisories. Recently we have changed kind of things in this forecast, like Aparabhaga and Sandhya Kala, we have changed them. Now we are putting at the time, exact time, this after this time, before this time, something like that. And most of the time now it can be understood after all. This one, fleet forecast, I told you about the intentional seas. Every day, twice a day, we should forecast for these grids. Of course, it's not kind of exact forecast things. We are just mentioning what is the wind condition and the thunder things, and as well as the rainfall, how is going to be rainfall, and the roughness of the sea, something like that. But here we are not much considering that. I mean, this is not for the small boats or things. This is basically for ships. So we can do this much better, because the ranges are quite okay with the observations. We are giving the ranges. The wind condition would be this range, and precipitation this one, something like that. This is kind of easy things. This one, locals as well as intentional seas. Again, this one also should be provided twice a day. This one especially for the naval people in Sri Lanka. So this one again kind of a forecast things in which is happening in the international airports in Katunayaka and as well as Mattala. Mattala is not functioning well, so these are not doing there, but in Katunayaka, of course, they are routinely doing this. And this one was not operated from here. There itself they operate these things and giving forecast. So four forecasters are working there, not 5, I think. Yeah. So usually they are giving kind of a short, or we can call it nowcasting. Nowcasting is something like this. We are observing things through many equipments and things, and then we forecast the predicted things for next few hours. So I hope that we would be able to do that in recent future. Sorry, recently we have done that as well, but we did not implement that one in operational way, because the thing was, if we are doing these things, I mean, if we are forecasting for next 2 or 3 hours, then it should be updated much quicker. At the moment, we do not have kind of a app things or something like that. We need to give those forecasts regularly through the same terminal we are doing with our regular forecast. So it's much harder. So that we just stop that one. But with the come of JICA 2 radars, we will be able to do that in a good way. So we are going with this nowcasting much fast way. So I think that the nowcasting is the one which can change people's mind, because I am telling you that nowcasting is something that we feel at the moment. Nowcasting, weather apps are always doing that. They are integrated with nowcasting, short term, long term, and some of them got seasonal forecast as well. But if you research on that, their nowcasting is the best. And when it comes to the mid-range, accuracy get less, and likewise when it comes to the seasonal forecast, it's kind of a failure. Yes, like us. So nowcasting can do many things. So we hope to do that. Okay, this is the flight region. I'll skip this. This region should be mentioned in aerodrome forecast and those things. This one, long range forecast, our people are doing kind of a thing here. So usually we are mentioning the probabilistic things. The season is going to get lesser rainfall compared to the last one, and compared to the average, the probability is much higher, lesser, something like that. So these forecasts are depend on basically the probabilistic things, and the cities they have mentioned there, and the figure you can see this one. This is kind of a theoretical things or the modeling things that our people done, because according to these charts, it says that the monsoonal rainfall is going to increase some place and decrease some place with the projection of next 20 years, 40 years and 60 to 100 years. So those are the projections. I'll show you kind of a clear picture more than this one, and of course I told you these long range forecasts are much important for the farmers and as well as agricultural people. Some of the statutory bodies who are working with us, especially the agriculture, fishery, oceanography and things, so on and so forth. So the Rio Declaration 1992, this was the point that people were talking about this sustainable development. So after that, many of the fields were required, were absorbed these things to their fields. So I told you why we are doing this. So it's basically the decision making with the collaboration or with the integration of few things, that is economic, environment and social considerations. So this makes sense, of course. The many things, everything is interacted with each other, so we need to have kind of a overall development compared to the single section or the isolated section developments. So why sustainable development? I was participating a workshop which was done by the JICA people. They have shown kind of a graph. So the graph was about the disasters and the money spent on their subject or the meteorology. So once the disaster things increased, the very next year the expenditure of money for that, for the institution or the Japanese meteorological organization is highest. Yeah, of course, a disaster is kind of a thing that we should not expect, but at the same time, disaster is the point where we can grab money for our development, especially the institution like ours. So at that moment, people or the governors understand what is the importance of these subjects for the development, because disaster costs a lots of money and the lives. That's it. Some of may would not agree with me, but that's the point. That's the fact. So recently, I have experienced this one in Mora situation, Mora cyclonic situation. Yes, we lost many things, but the ministers or the government agreed to ask us what you want to do to develop your institution. At least they asked that. So that kind of things happen. So at the same presentation, they told us and they proved that spending money on that institution is much lesser than that disaster. So once they got kind of a disaster, and then this disaster situation decreases, and then again kind of a thing happen, and then it decreases. That's it. So Ronu, I got kind of a sample here. So this one was lost. So I'm not telling that developing things in our institution would reduce all these things, but of course we can prepare. That's the thing. So these things are much, recently these things are happening over and over in Sri Lanka. So the severity of cyclones, of course, they are getting increased. Yes, one can argue with that. I argue with the climate change things and the urbanization. They got a kind of a broad area. Anyhow, the observation are these things. So the heavy rains, droughts. Recently we saw kind of a heavy rains around some area. At the same time, the other area we are facing a bigger drought. That kind of things happen. So the rainfall pattern is not much distributed, but some of the places get intense rainfall while the other rest of the country in a drought condition. So these kind of things happening. And this is the one I wanted to show you, the future projections of our department things. So this one was recently done in our department. Here it clearly say that this one was, let us understand the figures. Okay, the first column is the rainfall in southwest monsoon, or the, let us say, blue one are southwest monsoon one, and the yellowish one are northeast monsoon. So when it comes to the southwest monsoon, the first one, the first figure shows kind of a model that is related to 2020 to 2040 years. So that one is the first projection. Likewise, it goes 2040 to 2060, 2070 to 2090. So you can clearly see the southwestern parts rainfall is getting increased with the time, while the rest of the things are getting slightly decreasing. So and the other one in the northeast monsoon, again kind of a same behavior. So the rainfall accumulation is, the place is narrowing. Accumulation of rainfall is narrowing. Of course, in southwest monsoon we receive rainfall in southwestern parts, but this projection shows that the southwestern part itself narrowing with the time. So small portion will receive the rainfall according to this projection. Okay, I am not telling that these things are much correct or having kind of a greater accuracy, but many of the model forecast these things. These things are changed with the time because the carbon emission and the energy observing things, absorbing things, and those things, according to those things, these things also changing. But this is the present behavior. So according to these projections, these things happening, and nowadays we can see kind of a thing which is related to these projections. That is why I told you, while we are having kind of intense rainfall in southwestern parts in slopes, we are having drought condition in the other parts. That's it. So the extreme things is there. Tsunami things. You like to hear this one? No? Should I? Okay. Tsunami and earthquake monitoring. This at first the system was installed here in the department after the tsunami. And now the most of the people I am talking with, they are thinking that this system was here when the tsunami hits, and we were failed that. No, we didn't, at least. So this one was installed after the tsunami. They are after 2004. We got kind of a doubtful things with the system, but now of course this is much better, because this is the system now we are using. This one, of course, the interface of the earthquake and those things. If you got a smartphone, then of course you also have these kind of access to the real-time earthquake monitoring systems like USGS from the US government. There's app USGS, we call it USGS. You can have that one. You can monitor the real-time earthquakes. This one also using the same data, but kind of quality controlling is there, because this one was separately we are taking from them. And this is we call the tsunami system, or we call these three countries tsunami service providers. In our region, we got Indonesia, India, and Australia. So the system works this way. Actually, these three websites, we got separate logins. Of course, general public as well can log in those sites, access those sites, but the area we are accessing is prohibited for public. We got separate logins there because kind of a technical things happening here. I'll explain one by one. The first one, when kind of a considerable or the significant quake happens, then these three websites update separately about that same incident. So after that they are updating things, then we can log as well. So it updates the current conditions and what happened, where it's happened, and those things, as well as where is the threat, and many things are there like this. So the first picture is the energy released by the quake. So as an example, this one was happened in around Sumatra or somewhere like that. For your knowledge, we got kind of a two quake generating areas. The first one is this one, and the other one is around Pakistan area. So usually it is in the Arabian Sea. Usually this one is the bigger one. So a bigger quake can be happen around this area. So in this example, it shows the first figure shows the energy, and the second figure we have included the coastal cities in Sri Lanka which is having threat while in a tsunami. So pre-modeling things or the pre-calculation things shows whether we are in a threat or not. These calculations were done earlier. So according to the incident, they updates. So they are initially telling us, yes, you are in a threat, something like that. And the other one is a threat map, third one. So they updates their data as well. And the fourth one, traveling time. If a tsunami happens, then how much time it will take to reach our area. So this one is again it's pre-calculated. The thing is here, of course, tsunami or the earthquakes, they cannot be predicted at the moment. Japanese government, they are doing many researches on predicting tsunami, predicting earthquakes and those things, but at the moment it is not. So the thing is here, the region is having 2.5 hours away from us. That's the thing. Otherwise, we are nothing about that. So before 2.5 hours, of course, we can have an idea. Not only an idea, we can have a very good picture whether the tsunami is going to hit us or not. Because not only the system, I forgot to tell you that. In this system, I told you there are many countries in our region. They also log the system at the same time. So they update their current situation on this system. So let us say this tsunami happens, then the nearby countries, they update, they state that yes, we had a tsunami, something like that. Much simple. So that we can have an idea, yes, the quake generated a tsunami wave. Otherwise, you know, each and every quake do not generate tsunami waves. That's the thing. But especially, I am not accusing the media people thinks once they happens, yes, we are having a tsunami. Because last few days as well, some of the forecasters in our society, they are talking about tsunami things and those things. Then after that, once a magnitude of 6 happens there, then I think that was a Poya day or something like that. people have gone away from the temples as well. So that kind of things will happen in Mathur area. So these things are happening, and the thing is, this system is much reliable. That's the thing. And the other one, again, the US government and things are done here. So data buoy system is there, employing there. We can monitor those things in real time. Once a significant quake happens, these buoy system take readings in each 10 minutes or something, much in a smaller time scale, so that we can monitor whether kind of a significant wave have passed that buoy or not. So again, the system indicates kind of a good accuracy about those tsunami waves. In addition to them, we are doing these things for your knowledge, and that's it. I have shared you. Okay, so these things are here. Recently we have made kind of a Facebook page. Actually, starting a Facebook page, yeah, you can see it's kind of an easy thing, but you know what, we were doing, we were trying on that for months, because it's social media and we are a government institution. So we cannot publish things which is related to our subjects and our department. But once Mora happens, yes, we did this. We proved that, we convinced that once this kind of a disaster situation, how do we update the people? So that is how we obtained that chance. So our superiors, they were agreed with that, because at that time our website also collapsed. So we are having nothing to inform people. This is the present condition, because many of the people was about to spreading rumors and those things, not our data, our detail. So that was a golden opportunity for us. So these things can be accessed by you, and here I should acknowledge these things, our department, and as well as the foreign people, yes. And when I preparing these things, I took some of the resources from especially NOAA and IMD, and that's it. Actually, I forgot to show you the videos. This is Mora. Mora was not a cyclone in our area, but it develops to a cyclone. Again, this one is from Japanese government. Oh, it's not working. Okay, I'll close this one. So I think you better ask if you have any questions. Yes.
What was the reason that people publish things on the webpage? What government rule prevents you from publishing data on the Facebook?
It's basically it's a social media, because I don't know what is the things behind that. Because of its social media, we were asking about this kind of official page, official one in our from our superiors. They were asking, why do you want to go for FB while we are having a website?
So let me ask this question again. There is I'm Arjun member of the foundation. I think we those mics are going to not be recorded. Anyone?
Yes, my name is Arjun, a member of the Institution of Engineers, Sri Lanka. Now you mentioned that your senior officers, or rather the officers of the metallurgical department,
Yes,
were reluctant to publish data on Facebook.
No, at that moment we did not have a Facebook account.
That doesn't matter, but the point is that you were going to publish the data
Ah,
on
yes,
Facebook.
yes.
I have a very specific question. Is it because of a certain government rule, or is it the nuances of the people who say you should not publish?
I am not aware of kind of a rule, but it was the order. That's it.
Yeah, no comment.
So, anything?
Thank you for the information. Basically, I am curious to know how did we manage forecasting before? Before you had the computers and all that, so like you were saying, 60s.
Yeah.
How did we manage before?
This is what I have heard. I told you, I show you about the analysis things. So they were manually did these things. You know what? When I came here, it was something like the whole weather forecast was decided by seeing kind of a 2 or 3 lines over Sri Lanka. In analysis, yes, we have 2 or 3 lines over Sri Lanka. So these 2 or 3 lines decides many more things. It is basically the wind pattern. Yes, up to now, yes, it's basically the wind pattern who handle our weather. But in those days, there were no that kind of a numerical weather prediction things and satellite pictures as well. At the moment, we are receiving 10-minute satellite data, satellite pictures. So of course, it does not help on forecasting 2 or 3 days, but it's a great help when we are considering the present situation. 10 minutes data. But at that time, we have heard that they have received one or two satellite pictures from the US, and I have seen that they are kind of a thing that, you know, the old days we are watching the negatives from the films, something like that. It is not clear. They have to draw their own where is the cloud is by imaging. I mean, yes, there are some data, there is some data. Then they have to draw the things. Still the machine is there. At first they need to calculate, now the satellite is this path, it's a polar orbit one, this path, so we need to adjust these probes and these things to this way, and then it draws, manually draws, something like that. I have no idea actually how did they do that. At the moment we are doing 2 presentations in each day, so it takes 1.5 hours to finish it with a full of numerical weather predictions. So many production providers are there. I told you about the European Center for Medium Range Forecast, India, Japan, and ourselves. Many forecasts are compared to each other. Then we decide what's going to happen with our synoptical observation.
Yeah. One question and a comment. Next question is, okay, now we have moved so much. We have computers and all. Is it correct to say that our ability to forecast has improved in parallel, or is it always the same kind of technological improvement and the quality of the forecast has improved in parallel with that adequately? Or in the
adequately? That's a debatable thing. I don't know about that, but I told you I've been here for 3 years. Yes, it has been a great victory.
So it has helped.
Yeah, because I don't believe that we'll be able to succeed. I mean, this way, we will never be able to forecast exactly your area or your house is going to have rain, something like that. We will never do that. But of course, we have improved much better. This one is not working. I got kind of evaluation. This one was I'll show you this one. So I told you about the model that we are running in our department. So something like this. Okay, the slide indicates this kind of a thing. The first one, so you can see the upper title, valid for 3 UTC 28. That means the forecast and the things on this slide belongs to 28th of May. Okay, the first figure, this one, this forecast was made before 9 days, before 8 days, and likewise this one immediate day, previous day. This one is the observation. This one is the observation. You can
How do they match?
it's up to you. For us it's very good. Yes.
That's mathematical model.
Yeah, or the weather research and forecasting model that we are doing, and of course sometimes it's totally out. Yeah, this one you can see it fluctuates many times. It fluctuates. Before 9 days it does not predict any rainfall, but when it comes to the near, so previous day, it got extreme. So again it's wrong. But the pattern having kind of a relativeness. That's the thing. So likewise I'll go fast this way. Oh, this one is having a better picture. This one as well. This one.
You said a couple of things at the very beginning when you mentioned about the inventory of weather patterns. You said these models are given by other folks, people who do these models that you all are using.
Yes, it's not developed by us.
Formulas in them that
Yeah.
you don't even have a clue.
Yeah.
So basically, there are some hypotheses, the scientists, whoever who are doing these things knows what they are doing, right?
Yes, yes.
Okay. The data fed into the model, regular basis.
Yes.
There's outside data also being fed into the model, right?
Yeah, all the data is outside.
Right, that's real data being fed. And there's an iterative process in the modeling.
Yeah.
You try to simulate the scenario with the new data coming in and the past data.
Yes.
How significant is it for Sri Lanka? Now, I'm not talking about USA or India, large country. How significant is it for Sri Lanka, an island nation, close to a big continent? Sri Lanka is very close to a big continent.
Yes.
It's not like New Zealand, far out there.
Yeah.
How important is it to have models done that is very close to what happens in Sri Lanka or close to Sri Lanka relative to what might happen in, say, middle part or Hyderabad of India or something?
Yeah. It's totally different.
It's important to get very close to Sri Lanka.
This is in my presentation I did not mention this one. It is something like this. Yeah, that's a great factor we should consider. We are an equatorial country and an island which is close to kind of a bigger landmass. In a meteorological sense, we call it a landmass. So the temperature things and heating things are taking place around our area. So we always got kind of an excited atmosphere around us. So I don't know how did I forget that. That's the greatest factor I should mention in this presentation. I mean, why we cannot? Once ask why we can't. Of course, what is things? So we got 3 reasons. One is we are having kind of vast sea area around us. The other one, we are an equatorial country. The energy of the sun greatly received by our sea, and then they operates and the atmosphere is always excited. We don't know what happened in the next step. So the time resolution is much important. We need to calculate much smaller time scale forecasts that cost many computational powers. And the other one is the topography in our country. So it greatly different. So I showed you about the simulation I did. So it's because of that small mountain. It interact with that directional wind flow. So of course with that model, this one, weather research and forecast, we got kind of a low resolution topography data here. They calculate using this, that's one. And another one I have forgot to tell you, the thousands of formulas. We do not watch the whole things, but the scientists have decided schemes of those formulas. We are ticking on those schemes. Likewise, this way, thunderstorm. For thunderstorms, you should use this scheme. Once it's published in a scientific journal or something like that, we are trying on that. I was telling you that actually we need to do it ourselves. That's the thing. So at the moment, of course, we are having kind of a less amount of computers which was given by the foreign people. So we are trying on that. At the moment, they are running on that department, because at least we need to validate those data into 2 years or something like that. So it costs time. That's the thing. Thank you very much for asking that.
Two follow-up questions, and then I my chain of thinking is done. So we were wondering, having seen all these unwrapped new computers,
Yes.
and the data and all the scientific stuff coming out at the department, I need a direct answer.
Yes, I'll do that.
Can you ask what you said? How to apply those schemas? You know, when you do this simulation, that's a body of knowledge. You know, it's not just
Yes.
a computer.
Yeah.
And it requires a lot of work,
Yes.
time
Yes.
to get handle
Time
on.
is much important.
So how are we equipped in terms of this personnel at the department to handle this kind of sophisticated software and etc. etc. Number one, that is the first question. Do we have 25 of them in the department?
That's a critical question. Including myself, we got 3 or 4.
Okay. Second issue is that even if you have 25 people or 100 people, we'll have to work on it, and probably maybe another 1 or 2 years from now we will get a full handle on the how all the models work, right? I mean, it takes a while before you may know all the algorithms and everything.
Yeah.
But application of it and getting the hang of it, it will take some time.
It will take time. Yes.
So maybe another 1 year or 2 years from now
Yes.
will be better.
Yeah. Because I told you about those ECMWFA data that we are receiving free at the moment. So it also need to be validated.
By the way, just a quick question. How many of you are lucky in the country? I mean, what happens if you go to USA or Australia?
I don't know about that. Because you know what, we got that roster thing. I mean,
Actually, how many of such people are here?
actually the meteorologists.
How do you produce people like you?
At first, I think it's the training. Yeah, because at the university we don't have these things.
This training is being done by the department. Department said to
No,
No, that's
it's a foreign people. I've been in 2 training programs.
we don't read this kind of gentlemen. It's country systematic.
Yeah, once in Korea and as well as in Japan. I trained for 2 times in 3 weeks.
But you were sent by the department, right?
Yeah, according to their request.
But this is not a scientific field that
Yeah, that's the thing. In the university we don't have these things. That's a yeah.
Can you go back to your mind in that climate change slide there, 6 or 7?
And these things I told you about the gridding data and feeding those things. Actually, those were done basically by the supercomputers, and then we crop our region. After that, we feed those data into our model. That is how thing happens. Otherwise, we cannot do anything if we got raw data.
We must congratulate you for what you have done. Now we are looking at what we do next.
This one. This one, right? Oh, this one. This one.
That's one. Yeah. No, the blue one
Yeah.
is for the southwest.
Yeah.
monsoon.
Southwest monsoon things.
So over the years, what is the green patch? In the last one,
It's the increasing of rainfall.
Yeah, so
The
it's
scale is there.
It's continually increasing in the southwest.
Yeah.
Right. Now, is that the same thing in the other one? The northwest also, they have colored completely red. The bottom one.
It's decreasing.
Ah,
The bottom one is decreasing. Again, the scale is same. The scale is same. So
okay, so actually, what you are saying is the east monsoon hardly gives you any rain. Right?
yeah.
So this is basic. This is that wet areas you get better, and dry areas.
Yeah, the last theme of the World Meteorological Organization was that.
Yeah. That's so it is happening fast every time.
Yeah. According to these projections, yes.
So it is the first row, 1, 2, 3, 4, 5, 6 down. How do you count these?
Over the
I can't read it.
29.
yeah, this way.
Yes.
2020.
I'm trying to figure out which one is 2020.
The first row, actually this is what happens. We are calling something ensemble forecasting. That means, yeah, the first row is 45 ensemble members. The second row is 85 ensemble
That
models.
is for you. For me, I was very curious about this graph as well.
Yeah.
For me, none of those things matters. For me, what I want to know is which map shows 2007 to 2090, which map shows.
Okay. The first column, it's up to 2040. The second column up to 2060. The third column is 2090.
So the first row, what is first row?
First row is 45 members. I mean, the 45 model calculations.
So the bottom one is more sensitive.
Yeah. The best one. 85. Yeah, 85 ensemble means 85 models suggest this one.
So no wonder you say that you don't want to go out and say this is the way it is because this is a disaster.
Disaster, yeah, this.
This is a disaster because 2070 is not very far away.
Yeah.
50 years from now, we basically will have a dry country.
Yeah, something like that.
What we are facing right now.
Yeah. But in this sense, these things update because many things interact with each other when it comes to the rainfall. So according to these, we call these names carbon emission mode and those things. So according to the emission things and absorbing things, these are changing. But of course, the overall picture is quite okay. That's the thing.
Not very good.
Not very good, but good.
Sorry, in fact, one question, how practical is to make artificial rain?
For us, I think at the moment it's a dream because of the cost. This is like this, to form a drop of rainfall, a drop of water, it needs a nucleus. So usually these nuclei provide from the atmosphere. Usually it's a dust particle. In our atmosphere, of course, we got plenty of dust particles. When it comes to the artificial rains, the thing is there, the other factors are okay. I mean, now we got saturated water vapor. The thing is, it had not any particle, nuclei. so that we provide them. Usually it's silver iodide. Yes, it's silver iodide. Usually people use, so that it can accumulate or it can grab those water vapor. That is how it happens. But in our atmosphere, of course, we got plenty of dust particles. But you know, in my opinion, we need to search whether these conditions were satisfied, and those things need to be clarified much a precise way. So we need to use kind of a radiosonde thing or observing things. So it costs much money. At the moment, we are using just a single radiosonde. I don't think this would be practical in our country.
So if we can't afford that one, we will be able to afford that.
Yes. Yes.
Can I ask one last question? I would like to have your comment on this El Nino and La Nina.
Yes.
Where does it fit into this forecast? That's not a regular thing that comes in once in 4
Yeah,
years.
although it's not a regular thing, we are monitoring it regularly. It's because it's basically the sea temperature, sea surface temperature thing. So usually we can have an idea along the equatorial region. We can see the anomalous behavior of the temperature. So yes, it is kind of this thing. I showed you about the Madden-Julian oscillation. Again, Madden-Julian oscillation is also something like that. Where is that? This one. With the energy, it creates kind of a evaporating region. Yes, this is a whole big scale one when it comes to the El Nino and La Nina. Compared to the El Nino and La Nina, this one is much smaller. Of course, it has a great effect on our weather, and our people have discovered that one kind of a accurate way by using compared adequate years of El Nino and La Nina things. So at the moment I do not remember what is the effect when it comes to the southwest monsoon and northeast monsoon, but I can tell you this one, the same thing happens here in a small scale. So the thing is, this one shifted left and right. So if a region of evaporation shifted and downward motion around our area, then rainfall suppresses. And likewise, we received rainfall with current situations. I mean, current situation means the current season of our country. So it depends. Sorry, I didn't.
Do you believe that this artificial nucleus has impact on our weather conditions? Like according to whatsoever, this artificial nucleus, and there will be impact, the impact on the
If we use them.
yes, if we are going
At the moment, no one have discovered that, so I think I cannot comment on that because it's the chemical thing that we need to use. So air pollutant can be there, but air pollutant is kind of a different subject. I don't know whether our country we are monitoring that. I have no idea about that, but we are not doing. But again, it's a great thing that we should measure when it comes to that projections, because without having air pollutant data and the carbon emission data, we are much behind when we feed those data into those scenarios. So the accuracy of those 100-year projections get less. So there should be kind of a mechanism. In our country we do not have, I think, as far as I know, but in the other countries they feed those data. So interpolation is there. Always we are interpolating things. We are interpolating things, and we are making the new data. That's the thing. So that is how we rely on their data. I mean, those projections we are making are not ours. So actually the contribution of our data is much less. So we are measuring few things. So the other people are measuring many things. So we are getting interpolated, and then we get those answers for our area. That's the thing.
I think you may have answered half my question I was about to ask. Let me slowly ask this question, because today the computer power is available
Yes.
to do a lot of things without having computers in your office.
Yeah.
You
We can hire them.
You have a lot of new computers. My understanding about computers is, instead of having those computers in your office, spending all that hardware, etc., I believe you could rent. Tell me whether it's possible. You could rent a supercomputer or something for a period of time.
Yes.
With the data rented, not purchased.
Yeah.
And do the analysis and make predictions. Can you do that in the field of, in your field? Can you do that? Can you rent a supercomputer for 2 hours, rent the data, and do the analysis and make predictions? Can you do that?
I think we do not have that knowledge.
Okay,
That's
so you
the
don't know the answer to that.
Yeah. But the thing is, we are doing it actually.
Let me tell you, the reason I'm asking this. It is possible. So if I'm designing a car today, I can rent from Amazon a very powerful computer,
Yes.
or CG or some other company, EC or some other company. I can rent a computer for 2 hours or 3 hours.
Yes.
We don't need any of these computers on our desktops.
Yeah.
And also I can buy or rent algorithms and models and data
Yeah.
for that period. Then I can do the design and I can get my answers and leave it at that.
Yeah.
This car and this car.
Yes. Yeah.
I do not know whether it is possible for the data. Do you know whether it is possible for weather data to do that?
Yeah, you can do that.
You can do that.
Yeah.
Then the next question comes. Let's say the data is available with India, for example. Good data.
Yeah.
Or maybe next country, Indonesia or something, Australia.
Yeah.
What you are saying is that when it comes to Sri Lanka, close to us, even the terrain that we are in, the large sea at the southern parts, the big continent on the north, all these things put together, you may have to customize our analysis to very close to our country, right?
Yes.
Is it possible within the next 10 years or so that countries like India or Australia will continue to have better data about our country's conditions?
Yes, I think the answer is yes.
Yes. So if those two come together,
Yeah.
we can do very powerful predictions about our country by
Yes.
not having all these equipment and etc. Right?
Yeah. I hope so. Yes. Because it's basically the observation network.
Yeah.
We are in far behind. So if we are having kind of a long way of data, then it's possible. And at the same time, yes, this is not kind of a statistical thing always. It's a dynamical thing, so fluid dynamics. So in this slide, like Madden-Julian oscillations, we need to identify what are the seasonal variations, what are the phenomena that take place in our area. In many countries, in developed countries, they are using it called mesoscale models. That means a localized model. So once that model match with a certain area, it does not match another one. Likewise, so we need to create them ourselves. So something like is much important. And yes, when it comes to the calculation, statistical model or those things, at the moment we cannot.
Okay.
So that's it. Okay. Thank you then. Thank you very much. I had a great time here. Usually, yes, people are accusing on us, but they do not ask anything. That was a great problem until today, at least.
I would rather say, I don't know whether it's the right term in this our culture, but what you have not you, but people like you should do make meteorology very sexy.
Yes.
That's how they say it, make it very sexy.
Yeah.
Who wants to be one of you? I don't think any kid wants to be like you.
Yes.
But if you do talk about these things in simple terms in our own language
Yes.
and talk about the value of it, you can make this field very sexy. It is a very sexy field.
Yes, of course. Because after coming here, actually the whole thing was new, and as well as at the same time, it's a great thing to have, kind of a scientific feeling. So yes, people call us scientists, but we know how kind of a scientists we are. But we are far behind that. And thank you very much again.
So, the suggestion I want to make is you should invite the media for your presentation.
Yeah.
Video.
Yeah.
So we should create a weather
In near future, we are going to change our forecast for a city specific and kind of specific forecast things. So we are going to give kind of range things at that time. Of course, we are inviting them.
How many of people like your vintage, your age, your understanding are there in the network department?
Ah.
And why?
Yeah. Recently, 14 people were employed. 14. But in my age, we got 3.
But 14 people came on board.
Yeah. But the older circuits, there was not kind of the age limit. I'm not again not criticizing anyone, but when the people are getting older, the interest
You are being
gets
recorded,
less.
right?
Yes, I know that.
We can delete that part.
No, that's the thing, because the practical things, so they cannot move fast.
old dogs can't learn new tricks.
Yeah, now the time is 7, so I need to travel Venapur. So the thing is that,
We are not going to do that.
yeah, the people are there. So that's the thing. I'm not accusing them. That's the behavior.
Okay, thank you very much, Mali. Actually, this is the process of our long journey, I think, because as engineers, as I said earlier, we are very responsible for this part. So we are, I think, it was a very successful day. So Mali, Mali did very nicely he has done actually. So actually, in future we are going to do such a lectures. Maybe we can get from India or we can get from the land reclamation. So that's our task as ISL. So now I like to invite our chairman, Engineer Samar, to hand over the application to Mali.
Before that, one word. Malit and his team, especially for the meteorology department, they are playing with the nature. There may be plus or minus, but public and we all are believing you 100%.
Thank you. Thank you very much.
Thank you, Samar, and I must thank you all for participation. Thank you. See you next time.